Okay, so this can be a diagram of a Wheatstone bridge. We can see there are four resistors here, R1, R2, R3 and Rx. Rx is the unknown one and R3 is the variable resistance, and R1 R2 ratio is the 10:1 ratio. It depends on how it is defined, but I will just explain assuming that. So it can be different as well. So it could be R2 over R1 as well. So anyway, I will go with it, go through it first. The working principle, especially because the problem is actually just a formula which is not very difficult, the solution, but I will try to explain how we arrive at the formula. So we can see that there is a connection here between these two nodes. This one, let's call it A and B, and this is connected by a galvanometer, D'Arsonval galvanometer. So this one actually is there only to do the balancing. When there is a balance, when the galvanometer is not showing any deflection, that is when we say that the balance is achieved, and that means that there is no current that is flowing through it. So basically that is achieved by varying this voltage. This voltage is varied so that there is no deflection here, and that means that there is no voltage drop, there is no current through this branch, and that also means that the potential VA is equal to potential VB, because they are both at the same voltage. That's why there is no current flowing through that. So when that happens, when balance is achieved, we will talk about that situation when balance is achieved. So let's say the current here is I, and this current is I1, and when balance is achieved, this I1 will go through this branch as well. And similarly, let's say this current is I2, and that will go through this one as well, I2, because there is no current in that red branch, the branch which has the galvanometer. So since VA and VB are the same, and this is same node, that means the voltage drop I1, this will be, this is I1. So voltage drop I1 R1, that is the voltage drop. Maybe this is getting clumsy, so I will use a different color, maybe, I don't know, maybe this one. So voltage drop across here is I1 R1, that will be equal to I2 R2, because the voltage drop at VA and VB are the same. That means whatever voltage was here, they are the same voltage for both branches, because it's the same point, and that one minus this one will be equal to that one minus this one. So if that was, I don't know, V1 maybe, so V1 minus VA will be equal to V1 minus VB, because VA is equal to VB. So that means I1 times R1 will be equals to I2 times R2. So we can write I1 over R2 is equal to R2 over R1. We can write that from here. So I1 over I2 is equal to R2 over R1. I1 over I2 equals to R2 over R1. Similarly, the voltage drop from here to here, whatever the voltage drop from VA to this point, if it is V2, VA minus V2 will be equal to VB minus V2, because V2 is the same point, and VA and VB are the same. When balance is achieved, we are talking about that. So VA minus V2 will be equals to VB minus V2, because VA is equal to V2. VA equals to VB, because balance is achieved. That means this current I1 R3, I1 times this voltage drop I1 R3, this is VA minus V2, the voltage drop across this I3 branch, will be equal to I2 Rx. So we can write I1 over I2 equals to Rx over R3. So here I1 over I2 is equal to Rx over R3, and here I1 over I2 is equal to R2 over R1. R2 over R1 here actually. So we can write Rx over R3 equals to R2 over R1. So Rx, this is the formula that we need to use, and we don't have to derive it unless we are asked to, but I thought thought of explaining that as well. But when we are doing the problem, we probably have to just write this one. So this is the variable resistance R3, and the problem says here is the variable is 276, and that's this is sorry 2 I don't know, this is 276. So that's 276, and here we have, if we say 10 is to 1, 10 is to 1 means R1 is to R2. If it means that, then this will be 1 over 10. So the resistance will be, the unknown resistance will be 27 over 6 ohms. But it depends how it is defined. So if you have to take care of that. So what is R2 and what is R1? But this talks about the ratio R2 over R1 or R1 over R2. That you have to be sure, because usually it's given with the problem that we are talking about this ratio or the other one. So it can be R1 over R2 is equal to 10 is to 1, or it could be R2 over R1 is equal to 10 is to 1. So depending. So I'm just assuming that R1 is 10 times than R2. So basically that, and that will give me 27.6 ohms. If it were R2 was 10 times over, then we would have 10 on the numerator and 1 in the denominator, and that would give 2.7 kilo ohms, basically 2760 kilo ohms. Anyway, ohms, sorry. So that's the unknown resistance. So yeah, I thought of explaining the derivation of the equation as well.